Okay, there we go.
All right, we're on Memorex. Okay. Um, do you have any kind of a presentation to make first off?
Uh, Presentation as in the vehicle itself or like a slides
Any
or?
kind of a PowerPoint or anything like that?
No, sir.
Okay, then we'll go right into the rocket. So what we'll do is we'll start from the back and we'll go work it through. So do we have a camera where we can see stuff on the rocket?
Yes, sir.
Just
I'm gonna
slide
go
that
ahead
all the way
and roll
forward.
Yeah, you can just call me Steve. I'm fine with that.
Okay, excellent. We're gonna roll you on forward, and you want to be the cameraman?
Yeah.
Okay.
Okay, so the first thing I want to see, let's look at the back end, how the rocket, the motor is retained in the rocket.
Okay. So as of right now, this is our final design. We have a just normal Apogee Aerotech retainer sitting on the thrust plate. Aerotech thrust
Okay,
plate.
and that's bolted on.
Yes, sir.
And how is the thrust plate attached to the rocket?
The thrust plate is attached to the rocket with three 3D printed, it's a PLA CF, so carbon fiber, high temp, so it can handle the temperatures at Spaceport. These will all be 3 epoxied into the inside too.
Okay, and what are you doing for surface prep on all your epoxy joints?
We're using, so I think we're using 80 grit sandpaper. We're using acetone to clean off, and then we're applying a very, very thin veil layer of epoxy to both surfaces first, wiping it off so that it gets into all the crevices, and then we apply the final coat of epoxy. That was recommended to us by Jim Jarvis, and he said that that was a good way to get bonds onto epoxy.
Okay, I'm good with that. Okay, and how are your fins? Okay, how are your fins held on? I see the external fillets.
Yes, sir. So right now, this is surface mounted. These are 0.37 inch thick fins, G10 core with 2 layers of 12K 2x2 twill weave epoxy onto the outside. This is an inch fillet right here. And right now we're in a little bit of debate with Jim whether or not we actually require more carbon fiber tip to tip. That was our original plan, but as strong as the fins are right now and with our fin flutter calculations, we actually don't believe that we need to add the extra weight of the carbon fiber tip to tip, and these fillets might be sufficient enough. We're still in debate with him about that to figure out.
Okay, what motor are you using?
What motor?
Yeah.
We're using an M1850W Aerotech 75 millimeter. It'll put us subsonic. We won't be going through any transonic regimes.
Okay, so you're an M as in Michael 1850.
Yes, sir.
Okay, what does your rocket weigh?
A rocket weighs, let's see here, pull up the exact number for you. Let's see here. Full weight with propellant is going to be 48.74 pounds.
Okay, what's your maximum acceleration?
Maximum acceleration, we have, I think we're doing, let's see here. We're doing 10.63 Gs.
Okay. Think about it. Right now for your relatively benign environment for the rocket.
Mm-hmm.
Think about it as far as the tip to tip. The
Right.
only comment I'll make is if anyone questions it, because I will not necessarily be the inspector at Spaceport America Cup. So
Right.
of course, if someone has a bug that they really want to see the tip to tip, that's not the place to do it.
Okay.
So think about it. you're, like I said, you're a relatively benign flight environment.
Mhm.
If you prepped well, you're probably okay. In fact, my biggest worry will be that you break a fin on landing, not during the flight.
Right.
So, okay, I'm good with that right now.
Okay, excellent.
Okay, so the fins are on. So while we're working towards the back end and working our way forward, where are your launch lugs?
So
And how are they retained?
launch lugs right now. We don't have them drilled just because we want to verify with Jim for final. We have 3 launch lugs. They are 15-15, just standard from Aerotech. 15,
Okay.
15 rails.
Why are you using 3 out of curiosity?
We've heard from multiple teams that just for this scale of rocket, 3 is good just to have extra security in case one breaks. If one rail button breaks accidentally on the field and we don't have any extras, then that's an issue there. And 3 just helps with the weight of the vehicle on the rail.
Okay, I mean, if you want to go with 3, that's fine. The biggest issue with 3, of course, is alignment.
Yeah, right.
So at least 2 points, you're always short of alignment.
Right.
Okay, so where are they mounting and how are they mounting?
So for these, we have, we'll go at the aft one first. We have them marked on here with Sharpie here. Rail button 1 will be 1 inch north of the bottom of the tube. Rail button 2 will be 6 inches north of the bottom of the tube. And then rail button 3 will be 1 inch south of the top of the fin can. So 1, 2, and then 3.
And what's the distance between them? Between the furthermost and the aftmost?
Furthermost, aftmost.
About 22 inches, it looks like.
22 inches, yes, sir.
Okay. How long is your rocket?
Our rocket right now, if I remember correctly, it's 85 and an 18. Yeah, 85.125 inches tall.
Okay. What is the blue band on there?
Blue band, that is actually just masking tape.
Okay. Okay. So, what is that? How are you actually mounting the buttons on there? You screwed through the tube? Do you have any nuts on the backside?
So screwing for the tube, the Aerotech ones come with this, they come with the steel
T-bolt.
threaded back plate. We're going to
Yep.
use that, and we're also going to reinforce it even more, just because, you know, that just being conservative on the weight of these things. These things are a heavy rocket, and if they tend to slam around or they get dropped onto the standoff on the rail, these things can break. So we're going to use those to grab on the back and the inside of the tube, and we're going to reinforce it further with probably some extra epoxy.
Okay, I'm good with that. Just looking down at the rocket there, 22 inches, I can live with it. Is there any chance of moving the forward rail button any further forward? Or do you into a parachute compartment or something?
We're into a parachute compartment that we start going into the parachute tube. Our fin can's main tube, or fin can's main fuselage is 24 inches tall and a couple
Okay.
inches. So
Okay, so so let's go. We're on the pad. You're gonna launch the rocket. You launch it. What is, I assume you're gonna have your drogue deployment first.
right.
Okay. Hopefully that is set to go at apogee.
Mhm.
Okay, when is your backup charge firing?
Backup charge firing for drogue. So main charge is 4 grams of black powder. Backup
Okay.
charge, if I remember, is 6 grams of black powder.
Oh boy, you want to make sure you get that thing out.
Yeah, yeah. Well, yeah, I want it out. Yes, sir.
Okay.
For
So-
both. Oh, yes, sir. Go ahead.
So the question is how long after the first charge fires are you firing the second charge?
Plus 1 second.
+1. Okay, that's what I wanted to hear.
Mhm.
Okay, keep going.
So for both of those charges, both of those charge wells have 2 igniters in them. So we have 4 igniters in total going to 2 charge wells for the drogue deployment.
Okay, are you using a Raven, a featherweight Raven or similar?
We are using for Flight altimeters, we're using 2 RRC3s and an RRC2 plus.
Okay. All right, I'm good with that so far. So the drogue is out. So what I want to see you do a couple other things there. Is your drogue compartment vented at all for external pressure?
Yes, sir. So all compartments are vented. On the fin can, we have a 1/4 inch vent hole right here in the center.
Okay.
On the parachute department, we have a 1/4 inch. And for the nose cone, we have 4 1/4 inch vent holes for making sure that the temperatures are getting the correct.
Okay, you only have one parachute compartment?
Yes, sir.
Okay. All right, and you're using black powder to deploy?
Yes, sir. For our drogue, we're using black powder, and for our main, we're using a TD2.
Okay. All right. All right, so what we'd like to do is let's separate the rocket, just walk the sections apart. Are there shear pins, by the way?
Yes, sir. We're gonna have 4 number 4 shear pins connecting the fin can and the top section.
Okay, and you've done ejection testing?
So we have done ejection testing for the main. We originally had planned to use Paragene, the 8-gram and 12-gram cylinders. We tested those. Those are underpowered, and we did not like the performance provided. So we just went ahead and switched back to black powder. The testing of the main is dependent on another item that we should have done on 6/20. I think we have it written down.
5/20.
5/20.
I hope so, because 6/20 is going to be late to the
Yeah,
game.
yeah, that'd be just a wee bit late. Yeah.
Yeah. Okay, so what I'd like you to do is just walk the sections apart like it would be separating in flight. I just want to see how the drogue plays out. Is it packed for flight?
Yes, sir.
Okay, like I said, just walk it apart. You can slow walk it. I just want to see how everything falls out. And if you can aim the camera down slightly lower, it would be great. There we go. We're great. Okay, let's go ahead and deploy the drogue.
A little bit of friction and so here's
Because it should be falling out as you pull on that.
yes, sir. So the shock cord that we have now is not the shock cord we're going to use for flight. It is a 2,500 pound shock cord I use for my L2. The shock cord we're using for flight is going to be 7,500 pound tubular Kevlar from Bad Hawk, and we're working with them currently to get a custom made 5 loop, and we're working on it currently. We're trying to get that one in.
Okay.
So this year is for demonstration purposes, and it doesn't accurately show the lengths of it. The distance between this part here and the top section is going to be about 20 feet. And the way that we have it set up now for demonstration purposes doesn't allow the drogue to actually get pulled out.
Okay. So what is the forward restraint there? What is that bolted into, that eye bolt?
So this here, this is that's where our payload is. So this is payload. Let me actually just put this vertical.
Yeah, go ahead and put that down.
So the payload here, let me actually just unbuckle this so we can take it out and
That's
show.
fine. That's fine.
He's mentioned the welding on the bolt.
Yes.
Okay, this is your payload I'm looking at there, the white block?
Yes, sir. So this right here is our payload. It is a mild steel that's hollow through the center.
Okay.
Mild steel. And then we have a 3D printed sleeve that fits over it to fit the CubeSat format. And this slides over the 75 millimeter motor and bottoms out on a centering ring.
Okay. What keeps that from moving fore and aft during flight?
So this is something that's been we've been talking with Jim about. What we're going to do for this is what we would like to do is basically drill and tap the steel and have it we're gonna have the 2 screws. We're gonna have 2. I think we're gonna do 5/8 screws. They're going to bite into the top of the knurling on the top of the motor mount, pretty much into the
I'm
casing.
not a big fan of that idea.
So that was something we were talking with on Jim, whether or not that was considered SRAD when you're changing, when you're starting to mess with the motor. We're not changing the motor itself. We're not modifying the motor.
Right.
Just having 2 bolts basically bite into the aluminum.
First off, I'm not sure if you got enough strength there. I mean, you got, 10 Gs, you got 8, well, during deployments and stuff, you got high shock loads. I'm not sure I would trust biting in. Just go show the forward part of the motor there. Just let's just look at the forward part of the motor where you're going to hook that up. My recommendation would be is instead, and using more than 2 screws, would be is to try to go into after the knurl where you have that concave area. Oh, aft.
Here? Right here.
Right. Is try to make
Oh.
some kind of a collar or something and go into that area where you don't have to bite into anything.
Okay. Just have a bolt rust up in there, and so it
You
can't
have a
come out.
bolt
Okay.
in there. If it could go into a sleeve, in fact, if you could put some kind of a collar on there just to keep it from moving around,
Right.
that would be my suggestion. I
Okay.
would prefer, I think it'd be more secure. And I would prefer that, that's really what I'm looking for, is more secure.
Okay.
So is that eye bolt on there? Is that a forged eye bolt or?
So this right here, do you know the complications of Rocket Man in the past couple of months? Have you
No, I
heard?
did not.
So this was a problem that a couple of the other teams have been having, where we ordered all the way back in February, I think.
Yeah.
We ordered our parachutes, all of our recovery equipment in February, and they accepted payment and did not manufacture our parachutes for almost 3 months.
Okay.
I guess Kai or Buddy was on vacation. We don't know what they're happening, so we canceled the order. And we originally had forged eye bolts, and they were supposed to be coming from them. We have since changed to fruity shoots, and we're going to use a Rocketman drogue if he's still in business. But we just have this non-forged eye bolt for demonstration purposes.
Because that eye bolt that's there right now, it's a bent wire eye bolt, is not acceptable.
Right. Yeah.
Okay.
Yeah.
If you need to use that eye bolt, if you've got access to a weld shop or something,
Cool.
if somebody can weld the eye bolt closed, would be acceptable.
We will not be using any open eye bolts at all. We're ordering a forged one. This is just
Okay.
for demonstration purposes that we went up and picked from Harvard.
Okay,
Harvard.
you should be able to, like at an Ace Hardware or a good,
Yeah.
well-equipped hardware store, you should be able to get forged eye bolts at a
Okay.
hardware store.
Yeah.
You don't need to go to Rocket People for that.
Yeah, the one I think I went to Harbor Freight, and there was unfortunately no forged eye
Harbor
bolts.
Freight's not good for hardware.
Yeah.
Like I said, I'm not sure if you've got Ace Hardware down there or not,
Yeah, we
or
do.
True Value. I would go in there. A good hardware store with a good hardware selection
Mhm.
should have forged eye bolts.
Okay. Gotcha.
Like I said, you will definitely get flagged for that.
Yeah. Oh yeah. Yeah. Of course.
Just note that we can get them.
Oh, let me see
like
here.
Ace
Jim's
Hardware.
trying to enter the chat now. Okay, you have a minute here? Okay. All right, Jim should be in here now.
Okay.
We sent him the invite link at the same time as you.
Okay. All right. How you doing, Mr. Jarvis?
I'm hanging in there.
Okay.
Well, that's better than hanging.
All of them.
Yep. So we're going through it using your name in vain.
Are we?
As much as possible.
Yep. So again, you're the flyer of record. So basically, I'm talking. No, you're kind of the fly on the wall. So I'm talking to the team, and if you need to interject something, please do.
Okay.
But let's let the team do all the responses where possible. Okay, let's go back to the rocket.
For the eye bolt up here, it will be cotter pinned so that it does not rotate out during flight. And there
Okay,
will be
very good.
springs.
Very good. Yeah, the only other thing on the payload is I think you meet the letter of the rules.
Mhm.
I'm not convinced that you meet the spirit of the rules. That's just something to think about for next year.
As in the hollow core in the center.
The hollow core going around the rocket motor.
Okay, gotcha. So
I don't have an issue with you for the competition. Effectively, I went through a lot of this discussion with a team that I'm the mentor for.
Mhm.
So, yeah, you're legitimate, but the spirit of the rules, not quite.
okay.
Yeah, next year we're intending to have an actual experimental payload,
Right.
so it won't be like this next year.
Okay, how many of you are going to be here next year?
Next year.
It's like everyone but me and Lou, right?
Yeah, pretty much.
Yeah, almost our entire team.
Yeah.
Okay, very good. Okay, so the drogue is out. You're falling. When are you going to put your main out?
Main's
What
coming out
altitude?
we have it coming out. The primary charge puts it out at 1,000 feet, and then redundant charge puts it out at 800.
Okay, and you're using a single tender descender.
Yes, sir.
Okay, and you've got two electric matches or bridge wires in there. Okay, very good. Okay, I'm not sure to what extent you can demonstrate any of that right now. Did you get your parachutes, by the way?
So we have our fruity shoots main that we've been trying to get. So we replaced the Rocket Man main with the fruity shoots. It's a fruity shoots 4-inch ultralight compact, and the drogue.
4-inch? Did you say?
Sorry, 4 feet. 4 feet in
Okay,
diameter.
that is the main, right?
Yes, sir.
And what is your descent rate on that?
Descent rate on that is, I think it's 34 feet per second.
And that's I think that violates the DTAG. I'd have to go look.
The max is 36 feet per second.
Okay. Okay, so you're going to come down hard.
Yes, sir.
Um,
We're trying to minimize our walk a little bit.
True, although with the surface mount fins, I would give you a good probability that you're going to bust a fin.
Okay.
The good news is I think you're forward swept on the trailing edge, so it's less vulnerable. Let me just look at something here real quick.
I think it's 36 feet per second on the main, and then I believe it's below 100 feet per second on the drogue.
Okay. I got the DTAG up. I'm just taking a real quick look at the DTAG.
That might be a reason to do the tip to tip.
We'll just have to see how much it'll weigh. I think of the DTAG, it's either 11.0 or 10.0. I believe is the parachute section of recovery.
Yep. Okay.
I think 11.0 is actually launch pads and rails, and 10.0 is recovery.
Uh, 10 is launch and trajectory.
Oh, okay.
Let's just try. Let's see if we can.
The one you're referring to.
Okay, so the descent rate, you are correct, on the main is less than 11 meters per second or 36 feet per second. So you are correct.
And then drogue is 100, if I recall.
Drogue is actually 65 to 165.
Oh, okay.
So, all right, you're good there.
Yeah, I think I would like to interject that. And we talked about this, Will, but we need to. Well, first thing you need to do is just verify that descent rate. Because if it's using the Fruity Shoots descent calculator, that is at sea level, and you won't be using the chute at sea level. So you may be above that velocity, which, in my opinion, you shouldn't be bringing the rocket down that fast.
The Fruity Shoot descent calculator showed us 32. When we put it in RockSim, it showed us 34. So we're using the highest known value.
Okay, and that's altitude adjusted then? you
Yes,
think?
sir. I think it's at the 4,300
All right,
AGL or above sea level that the launch site's at.
and what size Fruity Shoot was that?
It's a 4-inch ultralight compact.
foot.
4
Or sorry,
foot.
4 feet ultralight compact.
So, okay,
The one bit of good news is Fruity Shoots generally have a pretty high CD on them.
It's a 2.2.
Yeah.
So much better than Rocket Man shoots. Saved a lot of weight.
Okay.
well, let me just say this, I mean, I'll look at it and maybe we can discuss that, but if all else fails, I'm gonna give you a larger chute.
Okay.
If it's a matter of cost, I mean, I have some I can give you, but you should be bringing a rocket down at not more than 25 feet a second.
Okay.
Okay.
Gotcha.
And I would very much concur with Jim's advice here.
Then write that one down.
Yeah. And then, like I said, especially if this was an L3 certification that you were doing, I would say no.
Right.
Because there's a high probability you're going to break the rocket.
Okay.
You don't have a requirement to fly again immediately. You'll lose points for damage. But again, I concur with the 25 number.
Okay. Gotcha.
So look at it. I'm not going to flag it, but it's something that think about it.
Okay.
Okay. Can we see how can you pull the main out, or is everything stowed? It kind of doesn't have the right tethers on it.
So let me see if I can actually unhook the TD2. That's what's stopping the main from wanting to come out.
Okay, and you don't have the correct shock cords on there. So on your drogue, since you've gone to black powder, are you using any kind of a chute protector on there to protect it from the black powder blast?
Yes, sir. It's I believe it's a 4-inch tubing Nomex blanket from Fruity Shoots.
Okay, you probably should be somewhere on the order of about 14, 15 inches on a side, if I remember the sizing correctly.
Okay. For the space that we had up in the parachute bay, it did give us enough protection that we were comfortable with it.
Okay. Okay, I'm also going to recommend, and I'm going to write this up. I mean, you can do it at Spaceport if you don't have the time, but I would strongly recommend that when you have the correct components in your recovery system, that you repeat your ejection test.
Yes, sir. I believe we have it scheduled for 5/22.
So I can talk about this for a second while Will's fixing that. This is sort of our list of, let me see if I can adjust that, list of things that we're still working on. So as far as needs, our components, our flight parachute, we're waiting on the drogue and deployment bag from Rocket Man. We are also looking at a backup in case that's not a possibility. Those welded eye bolts, those are being ordered from One Bad Hawk. And then the custom shock cord that Will mentioned earlier, the 7,500 pound 5-loop shock cord. As far as testing, we have completed the GPS test, the tracker test, and we've completed a main deployment test. We will also be, We will also be recompleting that main deployment test and a drogue deployment test. Currently, the plan for that is to do that on May 22nd. That's pending the final machining of the payload. We are also planning to do a checklist rehearsal that will be complete by 5/25. And then our partial complete list here, we have an initial draft of all of the checklists except for the recovery checklist. We're working on the initial draft of that, and then we're going to do a full final revision. That will be done around the time of the checklist rehearsal, so 5/25. Our payload, we're waiting on the final machining of the payload. That's going to be complete on 5/20. I think it has an hour more of runtime that needs to happen. The avionics bay, we're doing a V2 revision that will be completed this week by 5/18. Drilling the vent holes and putting on the rail buttons, that was just pending this video review to make sure that the placement was acceptable. So that will be complete by 5/15. And then we're making an updated schematic of the rocket. That will be complete by 5/15 as well. And then we're planning to complete tube painting by June 1st. And now back to Rob.
Okay. How much of this is documented in your final report that you submitted?
As in,
Does the final report represent everything that you're planning to have for flight?
yes, sir. It should have, are you asking as in the final product, as in the rocket, or all testing?
Does the technical report that you submitted last week match what the rocket's gonna look like on the pad?
Yes, sir. Yes, sir.
Okay. All right.
Except for maybe slight changes to the parachute or trying to move a rail button more northward to get better performance. It's most things are sedentary and are solid in design now.
Okay, so this is the joint that you took right now. This is the only separation joint in flight. Is that a
Yes,
correct
sir.
statement?
Yes, sir.
Okay.
So, go ahead.
I would definitely suggest, because of with the tender descender and everything in there, and you're not having the right chutes, that you repeat your ejection test, that you walk everything apart, make sure everything plays out correctly on the rocket, that everything separates correctly.
We plan to be doing the ejection test about 3 times over, just to make sure that everything's good and that everything's running smoothly.
Okay, the other thing is, so you have you tested with the 4 grams and 6 grams of black powder?
Not yet. That's dependent on the machining that's going to be done on, what is it, 5/20?
Yeah.
Yeah. So
Okay,
that's
for that size rocket, that's a 6-inch diameter rocket.
yes, sir.
6 grams sounds like, one's a little bit of a heavy charge for the rocket, and 2, usually people don't go 50% over between their primary and their main charges. So you may want to also pay attention to that. You know, again, yeah, it's nice to kick everything apart, but to have a humongous charge in there stresses everything and burns stuff. So pay attention when you're doing your ejection testing to see if if you can cut back some of those charge sizes. If you need the 6 grams, then most definitely do it, but pay some attention to it. Okay, go ahead.
4 grams gave us 10 psi inside, and then the 6 grams gave us 15.
Okay, well, again, you need, you did your calculations, you know how much force it takes to break your shear pins. You've got friction between the sliding components. So again, you do your calculations, what's the force that you need, and that gives you a starting point for how much black powder, and then see how it works.
Okay, gotcha.
Okay, there's not a whole lot of point in me looking at the tender descender and stuff on there, because you don't have the right cords and everything, right shock cords and the like on there.
They're shorter than the ones we're going to get from One Bad Hawk, but they're lined up the same way, so it matches the line diagram.
Okay, let's look at your eBay. That's what I'd like to look is inside your eBay and how your electronics are packaged.
Let me go ahead.
Okay, and this is a fixed joint for flight that you're separating right now, correct?
Yes, sir. This is a fixed joint for flight. Allow me to just take the main out.
Okay,
Screw it. This is a 4-inch shoot cannon that's going to be permanently affixed to the avionics bay. All avionics are nose cone and up. There's no avionics south of the nose cone.
okay,
I guess it's a form of head-in dual deploy. Okay. All right. So this right here is our avionics package. So for main flight computers, we have RRC3, RRC2. These are the two redundant computers. And then we have a main RRC3. For batteries, we have 3 9-volts, just basic 9 volts. We are using the 9 volts or the 9-volt battery holders from DigiKey recommended on the wiring instructions from the
okay,
DigiKey.
just looking here at, okay, which way are the battery contacts situated when the batteries are installed?
The battery contacts are on the roof, and so it sits inside like that.
Okay, can the battery move aft?
No, sir.
Okay, and what's holding that battery in that it doesn't come back out? Are you putting anything on there to hold it in place?
Yes, sir. So there is a very large zip tie that goes around all three batteries and with one zip tie, and it holds all of them inside of the battery holders so they can't leave.
Okay, do you have in your checklist to use new batteries or
Yes,
check
sir.
your voltages and stuff before flight?
Let's see here, you got the checklist. On the assembly pre-flight checklist, we have right here. Let me see here. Plug in fresh 9-volt batteries or test the current ones.
Okay. Okay, one suggestion, if you're using brand new batteries, at a minimum, my suggestion is check the voltage with your electronics powered. I mean, because you can have a battery that puts out the 9 volts, but for some reason internally, it doesn't deliver current. So my recommendation is at least to put some load on the battery. No pyrotechnics during this test, but turn on your electronics and make sure the battery doesn't drop significantly on voltage.
Okay, gotcha.
Just again, test it under load, basically.
Okay.
Okay, let's go back down to your electronics again. Okay, so the boards you have standoffs that the boards are mounted on standoffs, or either they're printed standoffs or whatever on the
Yes, sir.
sled there.
They're printed standoffs and they give us about 1/8 of an inch beneath all the boards.
That's great. I see a tie wrap around the board here to the left. Is that board bolted down also, or is that the only thing holding that board in place, tie wrap?
This one.
This board, no, it's screwed in. The tie wraps are used for the batteries on the back for this is the
Okay.
Big Red B.
Okay, and that is the recommended battery for the Big Red B?
Yes, sir. That Big Red B came with the manufacturers. We bought it. Same thing for the featherweight GPS tracker. It comes with its own LiPo.
Okay, is the Big Red B the ham radio band, or is it the non-licensed band?
It is the 70 centimeter 100 milliwatt version.
Okay, so 70 centimeters, like 420,
Yes, sir.
450 megahertz.
420 to
So that
450.
okay, so that's in a ham band. Do you have any ham radio operators?
Yes, sir. We're two. I have technicians and we have another general on the team.
That's fine. We got a lease technician. That's all you need.
Yep.
Okay, let's go back down and look at the electronics again. Okay, with your terminal blocks and everything. By the way, that's a pretty nice job of packaging. I want to give you guys credit for that. And also the fact that you're using twisted wiring is good practice. So happy to see that. Where you go into the terminal blocks, are you doing any pull tests and the like?
Yes, sir. So everything on this electronics bay is pool tested to make sure that they do not come out.
Okay. And it looks
So
like you guys shrink wrap on connections there to keep them from shorting.
yes, sir. So for even the battery terminals, we have them shrink wrapped here. And then
Okay.
for pretty much every single terminal that we have here coming off, we have clear shrink wrapping on the screw terminals. And occasionally, it's hard to see, but throughout the wiring, we have shrink wrapping in order for them
Okay.
to hold their structure better.
Okay. Like I said, it looks good. That's a nice job of packaging. Again, I want to compliment you on the twisted wiring. So I'm happy with that. In fact, that's some of the nicer electronics I've seen.
Thank you. I try my best.
Yep. Okay. So you still got some work to do on the rocket.
Right.
My recommendation when I write, it's going to be just a real brief report to Ben, who's the secretary, who's basically honchoing the reviews. And I'm going to say basically, I don't see anything that stops you from flying. I think that you still have a fair amount of work to do. But basically, it sounds like your next two weeks are going to be quite busy.
Yes, sir.
So there's some stuff that you need to do. I'm just going to say is, the rocket, the team needs to finish their testing and get their proper flight components. So the last thing I have is, have you flown anything like this before, by the way?
I've done some complicated L2 flights that utilize this pretty much a very, very similar avionics and recovery setup to this one. So,
Okay.
so designing for a head-end dual deploy, I've done that before. So some of the designs for this electronics bay, I pulled directly off of that rocket because it worked for me there, and so I'm going to use it. So it works for me here. The
Okay.
T2s I designed for that, and some of the scale, yes, sir, we have done.
Okay. As far as checklists, so I don't need to see them in great detail at this moment, but there's a couple questions on your checklist. Obviously, you've got procedures for putting the rocket together.
Yes, sir.
And the check items.
Yes, sir.
Okay.
We have 3 pages of assembly and pre-flight checklists here. That'll probably double and triple once we start rehearsing the checklist.
Okay.
All this will be rehearsed, with just a section of 1515 rail. That'll be a launch rail. We'll go through the flow and make sure everything works smoothly. That will be rehearsed on 525 to make
Okay.
checklist as low as possible.
Okay. So now you go out to the launch pad. You're going to put this rocket on the launch pad. Do you have a launch pad checklist for arming your electronics and the like?
Yes, sir, we do. It's about a page long, and it will probably also increase in size and complexity as
Okay.
Okay,
It'll be looked at probably in more detail as when you get out there and they do the safety inspections at Spaceport. Okay, so the rocket's on the pad, and of course we have our usual wind issues at Spaceport. So let's assume for some reason you're scrubbed, like weather. Do you have a procedure for safing the rocket before you pull it off the pad?
Yes, sir, we do have a scrub at pad checklist.
Okay, good. Okay, so rocket was launched, it flies, it lands. Okay, you're going out to the field to pick up the rocket. Do you have a procedure for recovering the rocket?
So that is one of the only checklists we do not have yet. So that one will be worked on.
That is on this list.
Yes.
So that procedure is planned to be completed. We have the recovery draft listed on here, and then the full final revision will be after the rehearsal. So we're just waiting until 5:25. Oh, sorry. We're waiting until 5:25 for the checklist rehearsal. That's waiting on the drogue deploy test and completing the machining. As soon as that date has come and we've been able to go through the rehearsal, then we'll have the recovery draft done for the rehearsal. And then after the rehearsal, we'll do the full final revision. That should be done by 5:28.
Okay, the two main things that I asked about for the recovery checklist are, one, are you safing your electronics?
Yes, sir.
And two, before you do any significant handling of the rocket, are you verifying no unfired charges?
Yes, sir.
So, if I remember, the tender descender doesn't use black powder; it just uses or uses very little black powder.
I think it uses 1/4 gram of black powder.
Okay.
Very small.
Again, what are you doing to verify that you don't have any live charges? Obviously, if it comes down well, the tender descender, since they're both in the same well, had to go. But you've got right now a 4-gram charge and a 6-gram charge. If one of those doesn't go, what are you going to do to safe it?
So we are using pull pin switches, and what we're going to do, we're going to carry an extra, we're going to carry a bunch of them with us all the time. Once we approach the rocket and we find it on the ground, we'll find the upper section, we'll put both pull pin switches in, and we'll bend the pull pin switches so that they cannot come back out.
Okay.
So that they're safe.
I didn't see, where are the charge wells, by the way, for the drogue?
So charge wells for the drogue. So this white component here that's 3D printed, this is the part that's yet to be machined with 3D printed, so you guys can actually look at it. The two charge wells are here and here. They're machined
Okay.
into the aluminum bulk plate.
Okay, and that you said is a tender descender there?
Yes, sir, right here. The TD2.
Okay, all right, it looks different from the normal TDs that I'm used to seeing.
I think those are the TD1s. The TD2s are, I guess, pretty much the same, but they're bulk plate mounted here.
Okay. All right, just want to check something real quick. Okay, you are, I think you're good to go. That one coupler I'm looking at that's the nose cone right there. So it doesn't have to be the one caliber.
Yes, sir. It's 4 inches deep.
Okay, well that's a fixed joint for flight, so I don't have a problem with that.
All of the couplers are 1 caliber, extended and inside of the appropriate components.
Okay, so the question I'm going to ask you is, what keeps you up at night about this rocket?
Oh my God. Okay, the biggest thing is the 100 feet a second off the rail of velocity requirement. That is one of the hardest things that we've had to deal with, and it enforces the entire design of the rocket. So we're flying the 75 millimeter, and we're having to fly 6-inch tubing because of the requirement of the CubeSat payload for dummy
Right.
payloads. That is extremely hard to get this rocket off the rail at that speed.
What is your velocity off the rail right now?
We have it right now at 102.
Okay, well, you meet the requirement.
Yeah. So
Okay,
as of right now, adding 500 grams here, there is the difference between.
it's deadly.
Yeah.
I mean,
So-
as a practical matter, though, I mean, that 100 is what we would like to see.
Yeah.
Reality is, looking at the rocket, in your stability analysis, how many calibers of stability do you have?
You have 1.62.
Okay. I'm not real concerned about the rocket right now. I mean, if you came in at 98, I would not lose sleep over it. I mean, obviously you got to tell me not to lose sleep. So, okay. Anything else, Bobby, that you're worried about, or your team members?
If anything catches y'all's eye.
I think we're just really focused on getting the testing complete.
Yeah.
We will feel a lot more comfortable once we've been able to do the testing with our actual components instead of testing with non-flight components. And getting that checklist rehearsal done is really important for us so that we know that all of our guys know exactly what they're doing on the pad and that there's not going to be any, tiny things that we forget, any little mistakes. The more we can go through that checklist, the more prepared we'll feel.
Okay.
For whatever.
All right. And this is actually, go ahead.
Sorry, I also wanted to add that I feel like while we're most of the way there, we've got a good plan to get us the rest of the way. And I don't have major concerns from here to where we're going. We expect all of the things on the board to be done 2 weeks at least ahead of when we're supposed to travel to Spaceport. So I feel pretty good about us getting it wrapped up in plenty of time to be able to be ready.
Okay. And I'm actually, this is a time where I'm going to ask the flyer of record, since technically it's his rocket to fly, is Jim, what keeps you awake at night on this rocket?
I don't have any big concerns. Other than the main deployment. I guess one thing that we probably need to do is schedule one more visit before
Right.
things get too far, because once you start laying eyes on it, all the little miscellaneous details that need to be there, start popping up, like venting your nose cone. Are you, how are you going to vent for the altimeters, and where is that pathway? We talked a little bit about the rail buttons, just venting the tubes themselves so that things don't come apart, all those little kind of details. So, I don't have any major concerns. I think, there's a couple things I didn't hear about on the discussion as far as the weight, the payload weight goes. So I'm not sure where that ended up going, but we can talk about that. I guess I did have one question. I think you said there were 3 altimeters in the nose cone.
Yes, sir. 2 RC3s and an RC2 plus.
Okay, how come 3?
The more the better. It's just more redundancy. If we can fit them, we're happy to have them, and just better redundancy overall. I don't want the difference between a happy rocket on the ground and a squish rocket in a hole in the ground to be one altimeter. So
Just a suggestion there. Technically, 3 is not necessarily better than 2 for redundancy, because one of your failure modes that you actually increase is the possibility of a premature deployment.
Okay.
So, the problem is 3 may be better than 2 if you were doing some kind of a voting type, best 2 out of 3.
Right.
But then you get a lot more complex on your electronics and everything. So, not dinging you right now for what you've got there, but just something for the future. 3 is not necessarily better than 2.
Okay.
Sorry to hijack you there, Jim.
Oh, no problem. The other thing I would just say is, listen to what Steve says about that rail velocity. If you're at 95, no one's going to have a problem with that, with the design of the rocket. So don't let that, be the tail that wags the dog. Don't compromise something just for the sake of getting that velocity. Okay, you want everything to be what it needs to be, and not compromise just for that variable, because it just isn't. Nobody wants the design to be compromised just to meet that requirement. That
Okay.
requirement's quite high as it is, and they'd like to see it because there's a lot of wind out there. But you don't want to have something else suffer.
What complications at the pad and at Spaceport could we face if we actually do find ourselves under the 100 feet a second requirement?
Someone would probably look at the stability and the size of the fins and see if they feel like there's a concern that it's a little bit under. I don't think at that speed anyone would tell you that you can't fly if the wind is over 10 or something like that. I mean, if you have a, good stability, 1.5 to 2, so you're not gonna weathercock, you're not gonna, have an inappropriate design. I don't think anyone is going to have a problem. Frankly,
Yeah,
that
yeah,
100
again,
feet a second
remember-
is,
That 100 feet per second is a goal.
Mhm.
It's not a written in stone requirement.
Okay.
yeah, I mean, if you said it was 70, then, there would be some scrutiny applied. And you would be asked if you had a test flight, and you would be asked, how, what have you looked at for, how it's gonna come off the rail at that speed, and, those sort of questions. But if you're at 95, you're not gonna experience any of those questions, in my opinion. It's very-
Yeah.
Okay.
The 100 feet a second is a high requirement to begin with.
Right.
So 95 is not unsafe. It's just like says, that's the goal. But just don't let it compromise the design. You just don't want to do that for, for
I
that.
mean, as an example here for your trade, and again, this is up to you. You talked earlier about the tip to tip on the fiberglass or the fins.
Mhm.
And if you really think you need to do that, yeah, it's going to add some weight. So, in your engineering judgment, you're going to make a compromise between the added weight, added strength versus a slight reduction, an increase in your weight and a slight reduction in your velocity off the rail.
Right.
So you just need to make those decisions consciously. In engineering is about compromises. There's very rarely a perfect solution.
Do we need Jim's opinion about the tip-to-tip configuration?
No, I think we're
You
good.
guys can work that offline from
Yeah.
here. I'm good with the way it is. Again, I don't have a problem with it for flight. I have a minor concern with your descent rate that you will probably, if it was a L3 cert rocket where you have to be flyable after the flight, I would express more concern because of probable fin damage.
Okay.
But since you're basically flying it a single flight for Spaceport, I'll let you make the trade.
Okay. Gotcha. All right, that sounds good. We probably will most likely lean towards having a softer landing. Don't want all that nice carbon fiber work to go to waste. So we'll definitely take that recommendation to heart. We'll get to it.
Yeah, keep in mind, a lot of people would tell you 25 is too high. And they would shoot for under 20 as a rule.
Yeah.
So, the just kind of conventional thinking about what the descent rate should be.
Yeah, I mean the target that I tell people is 15, but 15 is very difficult to do with a heavy rocket. So 20, 25 tend to be where they fall. And again, the ones I've been seeing is if you're in the 20, 25 range, I'm pretty happy with that. Yours is the highest I've heard so far, and I'm a little bit antsy about that, but it does meet requirements. You are risking the potential for damage.
Yeah, we'll definitely take a look at that and reconsider.
Okay, I think, let me see here, just as
Again, you're making your trades too, because to put a larger parachute in there, you're going to reduce the descent rate, but you really need to make sure that that parachute's gonna get out, that you can pack it reasonably and you can get it out of the rocket.
Right, okay. Gotcha. So we'll probably lengthen the chute cannon, make it a little longer to accept a larger parachute. And we'll make sure that everything comes out real smooth during our deployment test.
Is that the Fruity Shoots 48-inch toroidal that's in the bag now?
I think it's a Fruity Shoots 48-inch, like, oh, what is it? It's a, let me see here.
I mean, I'm reasonably sure a 72-inch Fruity Shoot would pack smaller than what you just showed.
I think it's an ultralight, I think it's an ultra compact light Fruity Shoot. Forgot the exact terminology the Fruity Shoot uses. Let me see here. Let's see here. Fruity Shoots Iris Ultra Compact 48. That packing was not my best packing, by the way. That was more just kind of demonstration packing. But we'll probably be able to get it tighter once we actually do better packing.
What
Like I
is
said-
the size and diameter of your chute cannon now?
It's 4 inches, 4 inches diameter, 8 inches long.
Like I said earlier, as far as I'm concerned, this is a pass.
Okay.
I don't see anything that is hell no, you can't fly. And that is my recommendation. But you've got a fair amount of work to do in the next couple weeks.
Yeah.
Yeah.
Yeah, I did have one more comment I wanted to offer on the charge wells. Just kind of looking at those, and that's 3D printed, correct?
So this will actually be, so the white part here, that is actually to be machined. It's going to be aluminum 6061.
Okay. Yeah, my only concern about those is I'm not quite sure how to seal them, because you want to be able to, put multiple layers of tape over the top of those openings so that, you've got some slight amount of back pressure that's generated when the charges go off, and that shape might be, well, maybe it'd be okay. I guess if you just go side to side, it should be fine.
I mean,
Is it cross?
a practice that I do is I actually don't use charge wells. I build up charges inside of like Estes tubing and I seal it.
Okay.
So that it basically blows the tube apart, but it builds up full pressure before it sprays out the black powder.
Okay.
But again, I don't want to change the practice that you're used to.
Right. Okay.
If
Yeah,
you were flying,
charges that size should also have the E-matches at the top of the powder and not at the bottom of it. I'm not sure how your E-match is going in there, but when you start getting that size, you have to be concerned about just physically blowing the particles out before they burn.
the good news is you're a 10K COTS class. If we were talking a 30K flight where the pressures are reduced, we'd want to do a better job of constraining the black powder charges.
Okay. Gotcha. So, so with the E-matches on the top of the black powder, the way that we have them going into the charge wells, they go through the aluminum bulk plate, and they have an O-ring and are epoxied in place. So we can just extend those through the bulk plate some more so that they stick on top of the black powder, so that we can ignite it from the top rather than from the bottom.
My suggestion is when you do your ejection test that scheme out.
Okay.
Make sure it works.
Gotcha. Okay.
I don't have anything else. Like I said, this is a pass. If everybody is good, then I intend to see you at the Spaceport. Like I said, I may not be the person doing the inspections at Spaceport, but if you have questions, you are welcome to get a hold of me.
Okay, excellent.
Thank you so much, sir.
Thank you very much.
Okay. And thank you everybody for your time. Thank you, Jim.
You bet.
Thank you.
Thank you.
Okay, I'm gonna log off.
All right.
All right. When the recording, do you want the recording, sir, or you just send it?
There's an extra address that was in the paperwork to send it to,
Okay.
but you
Gotcha.
can send it to me also.
Gotcha. All right.